Hello everyone. In this video, we are going to look in detail about one of the major OOPS concepts, polymorphism. In Java, polymorphism is a process that performs a single action in different ways. If a single task is performed in multiple ways, then it is called polymorphism. The word polymorphism is derived from two Greek words, poly and morphs. Poly means many and morph means form. Hence, polymorphism means many forms. Popular real world example would be how you react to people of different age in a particular situation. Assume you are traveling in a bus. Someone steps on your feet. Your reaction would be different depending upon the person and the surrounding situation. You would react differently if it was a child, different reaction when it was an elderly person, different reaction if it was absolutely careless and unapologetic. Here, the single action is someone stepping on your feet, and the different ways you react to different people and the situation corresponds to the meaning of polymorphism. In Java, this is done with the help of the signature of entities or methods. That is, methods having the same name but different in number of parameters or type of parameters. Any Java object that can pass more than one easier test can be considered polymorphic. Other than objects of type object, all Java objects are polymorphic in that they pass the easier test for their own type and for class object. The only way to access an object is through a reference variable. There are a few key things to remember about references. A reference variable can be of only one type, and once declared, that type can never be changed, although the object it references can change. A reference is a variable, so it can be reassigned to other objects, of course, unless the reference is declared final. The reference variable's type determines the method that can be invoked on the object the variable is referencing. Reference variable can refer to any object of the same type as the declared reference, or it can refer to any subtype of the declared type. A reference variable can be declared as a class type or an interface type. If the variable is declared as an interface type, it can reference any object of any class that implements the interface. Types of polymorphism. There are two classifications of polymorphism: compile time polymorphism and runtime polymorphism. Compile time polymorphism can be also called as static polymorphism achieved through method overloading. Runtime polymorphism is also called as dynamic polymorphism achieved through method overriding. Method overriding. When the subclass or a child class has the same method as declared in the parent class, the process of determining which method to be called at runtime based on the object referred is called method overriding. An overridden method is called through the reference variable of a superclass. Determination of the method to be called is based on the object being referred to by the reference variable. Method overriding is possible only through inheritance. Anytime you have a class that inherits a method from a superclass, you have the opportunity to override the method unless the method is marked final. Example: the key benefit of overriding is the ability to define behavior that's specific to a particular subclass type. For abstract methods, you inherit from a superclass. You have no choice. You must implement the method in the subclass unless the subclass is also abstract. You could think of abstract methods as methods that are forced to override. Rules for overriding a method are: the argument list must exactly match that of the overridden method. If they are not same, you can end up with an overloaded method that you didn't intend. The return type must be same as or the subtype of the return type declared in the original overridden method in the superclass. The access level cannot be more restrictive than the overridden method. The access level can be less restrictive than that of the overridden method. Instance methods can be overridden only if they are inherited by the subclass. Subclass within the same package as the inheritance superclass can override any superclass method but is not marked private or final. A subclass in a different package can override only those non-final methods marked public or protected, since protected methods are inherited by the subclass. The overriding method can throw any unchecked or runtime exception, regardless of whether the overridden method declares the exception. The overriding method must not throw checked exceptions that are new or broader than those declared by the overridden method. For example, a method that declares a file not found exception cannot be overridden by a method that declares a SQL exception or any other non-runtime exception unless it's a subclass of file not found exception. The overriding method can throw narrower or fewer exceptions. An overriding method that does not have to declare any exceptions that will never throw regardless of what overridden methods declares. You cannot override a method marked final or static. If a method cannot be inherited, you cannot override it. Method overloading. Newer Java developers are most confused about are all of the subtle differences between overloaded and overridden methods. Make sure to understand the differences between them clearly. Method overloading is the process that can create multiple methods of the same name in the same class and all the methods work in different ways. Method overloading occurs when there is more than one method of the same name in the class but different in signature, that is, different in the number of parameters or type of parameters with optionally a different return type or access modifier. Overloaded methods let you reuse the same method name in a class. Example, rules for overloaded methods. Overloaded methods must change the argument list. Overloaded methods can change the return type. Overloaded methods can change the access modifier. Overloaded methods can declare new or broader checked exceptions. A method can be overloaded in the same class or in a subclass. So, two methods with the same name but in different classes can still be considered overloaded if the subclass inherits one version of the method and then declares another overloaded version in its class definition. Note: if two methods have same name, same number of parameters and only the return type is different, it is not considered as overloading in Java. Method overloading versus overriding. Method overloading generally occurs in the same class but can occur on inherited subclass as well. Method overriding occurs only with inheritance, that is, only with parent and child classes. Compile time, runtime. Arguments must change. Arguments must not change. Return type can change. Here, return type cannot change except for covariant returns. On method overloading, access can change. Access must not be more restrictive, can be less restrictive in method overriding. In method overloading, invocation reference type determines which overloaded version is selected based on declared argument types. Happens at compile time. The actual method that's involved is a virtual method invocation, happens at runtime, but the compiler will already know the signature of the method to be invoked. In method overriding, object type, in other words, the type of the actual instance on the heap determines which method is selected. Happens at runtime. Advantages of polymorphism: increases code reusability. It allows objects of different classes to be treated as objects of a common class. Class that are written, tested, and implemented can be reused multiple times. Improves maintainability of code. It reduces the amount of code needs to be written and maintained. Also, can make changes without affecting the original common code. Reduces time. Because of code reusability, dynamic binding, making changes without affecting original common code makes it easier to write generic code that can handle objects of different types. Becomes easier for programmer to debug as well. Disadvantages of polymorphism can affect readability, thus making it harder to understand the behavior of an object, especially if the code is complex. This may lead to serious performance issues as polymorphic behavior may require additional computations at runtime. Let's look at some examples to understand polymorphism in detail. First, method overriding. In order to demonstrate method overriding, had created a parent class called sample parent. In that, have a method print with parameter, print with exception, and a static final method, print static method. Now created a sample child class that extends sample parent. Here I am overriding the print method and just mentioning that this is from child class. Same with print with parameter and print with exception. So the idea of having this print with exception is basically to show that we can have a fewer or a narrower exception in the overriding method. So the parent class method throws unchecked exception, but here there are no exception thrown. It is perfectly okay. Even you can change it to IO exception. Still, this should be fine. But you cannot have this other way around. You cannot have a higher exception or a broader checked exception in the overriding method. This is one of the rules. Here the comment and line indicates you cannot override a static or a final method. We already have a static final method. Print static method in the parent class cannot be overridden in the child class. Also, the overriding method cannot have more restrictive access modifier. You cannot change this to protected. It will show error. One other method that I have here is print void, another parameter in this. This is simply overloading of this method. Let's say in case even this is present in the parent class without any of these methods, I'm simply specifying this. This will be considered as method overloading, not overriding. We can confirm that by adding the method override annotation. It will show the method does not override method from its superclass. So basically, here it becomes method overloading because of the variation in the argument list. Had created a class demo method overriding, defined a public static void main method, and then have object for sample child where I am calling each of the methods, creating an object for sample parent and calling all the methods. On the third part, I am creating an object for sample parent class, but I am creating the child object here. So because of this, the child object method will be called. While we will be able to access all the methods that are common to both parent and child, we won't be able to access the additional overloaded method from this object. It method won't be available. Let's execute and check the output. The output is printed as expected. In order to demonstrate method overloading, had created new class sample method overloading. Inside it, have a method print. Return type is void and access modifier is public. Then I am overloading the method with integer parameter, string parameter, boolean parameter with the different return type as well. Also, instead of one parameter, have two parameters on these methods. This protected method is simply to illustrate we cannot directly access it. Still, the overloading works. Only thing is, only the access visibility will be within the package and for its child classes because of protected access. Now here we have a throws exception. In the overloaded method, we have a null pointer exception thrown. You can even have IO exception as well. In overloading, you can have any kind of exception you want. Now, one thing that I mentioned is in case of overloading, if let's say parameters are the same, only the return type is different, then it's not overloading. Here it shows error because this is not overloading. Already a print method is there. The compiler will not know which print to call because there is no difference in the argument list. Now to check the working of method overloading, I had created a class demo method overloading. Defined static void main method, creating an object for sample method overloading class, and then calling each of the overloaded methods. In one of the method where I'm passing the boolean variable, irrespective of what I pass, I'm always returning false. This is just to check whether this is working as expected. Let's execute and check the output. The output is printed as expected. Let's recap with a quick 2-minute summary. In Java, polymorphism is a process that performs a single action in different ways. A popular real-world example would be how you would react to people of different age in a particular situation. Polymorphism is achieved through methods having the same name, but different in number of parameters or type of parameters. Any object it can pass more than one ACA test can be considered polymorphic. Other than objects of type object, all Java objects are polymorphic. A reference variable can be only one type, and once declared, the type can never be changed. A reference variable is a variable, so it can be reassigned to other objects unless the reference is declared final. A reference variable's type determine the methods that can be invoked on the object the variable is referencing. A reference variable can be declared as a class type or an interface type. There are two classifications of polymorphism: comparative polymorphism and runtime polymorphism. Compile-time polymorphism is also called as static polymorphism, achieved through method overloading. Runtime polymorphism is also called as dynamic polymorphism, achieved through overriding. When the subclass or a child class has the same method as declared in the parent class, the process of determining which method to be called at runtime based on the object referred is called method overriding. For abstract methods, you inherit from a superclass. So you have no choice. Abstract methods are methods that are forced to override. Some important rules for overriding. The argument list must exactly match that of the overridden method. The return type must be the same as or subtype of the return type declared in the original overridden method in the superclass. The access level cannot be more restrictive than the overridden methods but can be less. The overriding method must not throw checked exceptions that are new or broader than those declared by the overridden method. You cannot override a method marked as final or static. If method cannot be inherited, you cannot override it. Method overloading occurs when there is more than one method of the same name in the class but different in signature, that is different in a number of parameters or type of parameters with optionally different return type or access modifier. Rules of overloaded methods are: overloaded methods must change the argument list. Overloaded methods can change the return type. Overloaded methods can change the access modifier. Overloaded methods can declare new or broader checked exceptions. The method can be overloaded in same class or in the subclass. Advantages of polymorphism: increases code reusability, improves maintainability of code, and reduces time. Disadvantages of polymorphism: can affect readability and may lead to serious performance issues. Skill check. After every topic, there will be a set of questions with multiple choice options which you can use to self check your skill on that topic. These are derived by me for that topic. You can find the answers in the video description. In case you got it wrong, no problem. Explore and identify what you missed. This exercise will help you learning the programming language efficiently. First question. Second question. Third question. Fourth question. Polymorphism is another very important OOPS concept without which you won't find a Java application. Generally, method overloading is used more often than overriding. In fact, I try my level best to avoid overriding because of its performance impact. Every Java application that I have worked had polymorphism. I recommend not to overuse and, if possible, restrict yourself from using method overriding often. In Java interviews, the most asked questions revolve around polymorphism. Questions related to the rules of method overloading, overriding, difference between overloading and overriding are extremely popular. Make sure you have a clear understanding of the differences between method overloading and method overriding. Use polymorphism effectively and efficiently. Thank you.